Continuing in Chapter 1, Topic 3, more on functions and their graphs. Again, the objectives, you can pause. Now here we're going to look at to see whether functions are increasing, decreasing, or at a constant function. And this shows what it's like, but it's best to see when you look at a graph. So let's look at a particular graph and then pick out what we're seeing here. So this will be example 1. And this is our graph. Now remember, this is extending in both directions, but we're interested in what we see here. So as you look, this is coming up from negative infinity up to this point right here. So that's increasing, and then in interval notation, we use a parenthesis, negative infinity, and it seems to go up to about a -1. Again, we're talking about domain, our x values. Now, from -1, it's moving down, and in a sense decreasing, to about a 1 right there. And then from that 1, it's moving upward and increasing. So when you have something like this, this is how it's read. All right, let's go on. For background now on the relative maximum and the relative minimum. Again, if we look at a diagram, this shows it very well. So the relative maximum, as we see in red, would be, again, we're talking about x values, is a -1, while the relative minimum is a +1. So again, indicate that on a little sketch. Now here we're looking for a definition of an even and odd functions. Now for background, we're taking a look at the definition of an even and odd function. So read this slowly and carefully here. The function f is an even function if, and as you see here, the function x is negative, equals as if x were positive, for all x in the domain of f. The right side of the equation of an even function does not change if replaced by the x of the opposite sign. Now, the function f is an odd function if, and here we see our x is negative, if it equals a negative where x then becomes positive for all x in the domain of f. Every term on the right side of the equation of an odd function changes its sign if x is replaced by its opposite sign. All right, let's look at an example. Example 3. Determine whether the function h of x is equal to x to the fifth plus 1 is even, odd, or neither. So as we look at it, we're going to replace the x with its opposite sign, as we see here. Now, when we do that, this side and this side do not equal each other. So therefore, the function is not even. And looking at this, replacing it, again, one side does not equal. So the function is not odd. So in this case, the function is not, or the function is neither odd or even. And here they're stating the graph of an even function in which this equals this will be symmetric with respect to the y-axis. And what does that mean? Well, I'm going to give you a little brief example. Let me make a nice line here. So this is the y-axis, and let's say this is, oh, let's see, I don't want that. Our curve looks like this. Then symmetric to the y-axis would look like that. Just to give you an idea what they're talking about. All right. Going on, now we're going to take a look at what are called piecewise functions. And I'll go back to red here. Now, piecewise functions is when we graph something, and I'll just give you an idea what we're talking about. We get a piece of a graph where something may look like this, and then something may look like this. That both are on the same graph. It's pieces of things, and they give you certain restrictions that you must follow when you do the graphing. So let's go on to our next slide, and we see this is example 4. Given the function, now they usually set it up like so, where the function of t, this is 20, and they're saying this restriction, if 0 is less than or equal to t, and t is less than or equal to 60, in the second part, they're giving this statement, but again, qualifying it, t is greater than 60. So the first thing they're asking us to do is to find this. Well, 40, where does the 40 fit in to our piecewise function? Well, 40 would be in here, this restriction. So C of 40 is equal to 20 because 40 fits in there, and that's would be what applies to the 20. Now, when it says for part 2 of this, find C if it's 80. Well, here, 80 fits in here. 80 is greater than 60. So now we use this function, substituting the 80 and just following through, and we get then C at 80 is 28. So again, we're taking pieces depending on the qualifiers here. the restrictions. Let's go on. Now, this is somewhat tedious because we need to look carefully at what the parameters are and then get some points so that we can graph it. So here is our basic graph, and I'm going to write it up here. And I may have included this in your booklet too, so let me pause for a moment. Now, what I've done is I've copied all the data from that previous slide onto this, and then we'll sort of tease it apart to see what we have. So this was our initial function. This was our restriction. So again, making a t-chart is very useful. Now here they're saying that, remember, this can be substituted with the letter y equals 3. So for this value on this t-chart, y is always going to be 3. And looking at this, it says, what's our restriction? That x has to be less than or equal to -1. So my x is a -1, a -2, a -3, and so on. We got enough points. So when we go to plot this, we're going to go -1, 3. So -1, 3. And we put a dot right there. Now this is -2, 3. Dot right there. -3, 3. And if you see what's happening, we're getting a horizontal line that looks like so. And I'll put my arrow on that. And that's a piece of this piecewise system. Now, for this next function, and again, it's y is equal to x minus 2. But here we're saying that x is greater than a -1. So what we do is at -1, we're going to put a hollow because -1 is not included in the system. So as we go to plot this, so -1, -3, -1, -3, we're going to put a hollow because that point is where it sort of anchors it, but it's not included. Then 0, -2. 0, -2, we can put a dot there. And then 1, -1. Now notice we get a nice straight line here, anchored there, and going through these points. And again, this goes on here. We don't show it. So there's our graph, piecewise, based on this information. Now, let's take a look at the graph they give us. I'll clear this up and go back. There's the data, and there's the piecewise. Now, one of the things we might wonder is this a function? Well, using the criteria that we've mentioned, and let's use the vertical line test. We're going to pass this vertical line over the graph. Now it intersects in just one place here, but when it gets to -1, there's a solid dot, there's a hollow dot. So it's only intersecting the x in one place. Yes, this is a function. Going on to what is referred to as the different quotient of a function. So we have this expression, and it's this minus this, which gives rise to the difference, and it's divided by h. And h, recall, cannot be equal to a 0. Again, part of our vocabulary. Let's look at an example. So here in example 6, we're asked to, this is the function, and we are asked to replace the x with ax plus h. So there was the original x. We're replacing that original x with this. Now we're going to expand this binomial, get this, multiply through, get that. Just remove the parentheses here, and there are no like terms. So this is what this would be like replaced with this value. And again, pause, copy down what is needed. Now in the next slide, as we continue this, and I'll take this away here, we now need to finish the expression because now we're going to subtract from what we had in the previous part, which was this. So putting a negative sign right there, we just copy, this is x, we copy this down. What does this do? Well, this reverses all these signs within the parenthesis. So this negative 2x squared becomes positive. The positive x becomes negative. The positive 5 becomes negative. Now, as we look at this, you might say, can we simplify? Are there any like terms? Yes, this cancels with this. The 5 cancels with this 5. This positive x cancels with this x. Lots of elimination of things. So now what's left? Well, we have this, and this, which is what they've written here. Now notice there is a common a common h in each one. So I'm factoring out that h and I get this. Now what happens? Well, the h's will cancel out. Wow. This is quite tedious here, but then this is our answer. So hopefully you could follow it, and again, could always replay to see it again. Now, lots of stuff here, again, being exposed to vocabulary and then practicing by doing your homework and mastering this information are critical skills.